Then you start talking and then you say go every time.
All right. Hello, everyone. My name is Anwar, and I am working with the Scale Education and Development Center. Also, I'm helping Aarhus University, and um, the topic of my today's presentation is about towards ferry electrification in the maritime sector. And recently in this regard, we have published a journal paper in the mid of December, and the name of this journal is Energies. It has been present in the section Electric Power and Energy Systems. There, I have also mentioned the link where you can go if you can click onto the link, so then you can directly move to that paper and read the paper thoroughly. Michael, can you move towards the next slide? Yeah. The paper basically consists of a number of sections, as you can see on the slides. First is related to abstract, then introduction, state of the art, limitations, research methodology, results, discussion, and then finally comes the conclusions. So I will move from those sections one by one. As we already know that the electrification of vessels or ferries for green transportation require onboard electrical energy storage as well as an energy supply network in the port area. So the basic purpose of this research paper is to develop the knowledge by examining the current state of affairs, also to come up with some of the useful guidelines for the green transformation through vessel or ferry electrification. And we also know that a lot of research has been done in the last decade in the research, and also comprehensive studies has been done on the electrification of vessel in the industry as well as academia. So data has been collected in a very systematic way, and we have done comparison of different pure electric and hybrid vessels in terms of their performance and different attributes. For example, battery capacity, passenger and cargo capacities, its size and distribution of the vessel according to different countries, and what kind of manufacturers available in the market. And finally, we discussed about some of the challenges in the form of technical, operation, legislative, and also based on the human factors in detail in our research publication. And basically, the keywords that we used are already highlighted in my slides that we have used specifically focusing on this current topic. Next slide. As we already know that 80% of the world transportation is carried out by vessels or ships for the consumer goods, and we know that the maritime sector has been deploying a lot of fossil fuels, which is very much not only hazardous for the human health but also for the environment. And these hazardous gases, we already know that these are oxides of different gases, for example, carbon dioxide gas, sulfur dioxide, or nitrogen peroxide. So consequently, maritime industry has an impact on climate change, especially near coastal areas. Maritime sector is an important for the international economy, and this is particularly true for the European maritime economy, which is associated with short sea operations through ferries, including freight and passenger transport, and basically it accounts 70% of world's journeys. As I already mentioned, that fossil fuels is being deployed, so it is associated with a lot of leakage of chemicals as well as the hazardous gases into the air. Environmental concerns and the above explanation suggest and also urge the International Marine Organization to implement certain emission regulation. Although ferry operations are of great importance for the European maritime economy, European ferries and vessels do not have the required specification to counter growing environmental concern. And we know that many ferries that have been operating in the European region for the last 20 years have not been updated. That makes them a critical source of carbon air polluting sources. Apart from that, there is also an increasing trend towards the electrification of ships through a hybridization process. And in this process, renewable energy has been a lot of explored and also integrated under the umbrella of hybridization process. Despite the great importance of ferry electrification, definitely we know there are many challenges which are preventing the successful implementation of this technology, and these could be related to technical, operational, legislative, and human factors. Human factors could be like if they are not having the specific training about the proper implementation. Also, they don't know the safety issues of a new system, or they don't have the required competencies. So these are the challenges which still exist. And also some of the challenges are related to, for example, the voyage distance in case of fully electric ferries. Battery charging during the short port stays of electric ferries is a critical challenge. And also it requires, we know, specialized electrical infrastructure. The other thing is to use the lightweight material, which is very much important in case of the fully electric ferries. That how can it be very lightweight? And also there are challenges available in case of legislative point of view. Next slide. Yeah. So we have been moved through a lot of recent publications and the review surveys, and then we decided to go for the very latest one, and then we particularly use the surveys from 2018 to 2019. And in this table, you can see that we categorize these review surveys according to the categories which are mentioned in the table. If you can see the first, and I will give you a little bit detail about what those review surveys were mentioning about these categories. In the first category, which was about the review of electrical energy sources, propulsion and power system, the authors basically they have seen or did the research to improve the overall efficiency of the ships. The authors in particularly target the conveyor and emission of heat energy generated by the engine to the propeller. They have also observed that the use of electrical power system decreases energy conversion losses, while direct current system provide low fuel consumption as well as decreased emission. In the second review survey, they have seen the use of liquid gas instead of fossil fuels, and they said that it is beneficial for decreasing the ship's carbon footprint, and they have also mentioned some of the techniques for installments of the different equipments for the ship as well as on the port area for this for the electrification. But these review survey also have some limitations. They did not address various energy storage systems, similarly different configuration of hybrid and pure electric ships. So in the second category, we actually mentioned in our paper that these review surveys basically move through The microgrid and their complete power system design have been discussed in the review service. And microgrid basically is a mature technology in the terrestrial environment. However, in the maritime sector, there is still great potential to use the technology. And they have also mentioned that that the ship energy efficiency depend on the ship design, fuel type, and also operation of use of those ferries. In the third category, energy storage system to improve the fuel efficiency of the ships is mentioned, and they have discussed that all electric ships to improve the fuel consumption without the emission of hazardous gases should use the same electrical network to drive the propulsion as well as the service equipment. In the fourth category, which is related to fuel cell, battery, hybrid, or full battery powered ships, they have discussed that the fuel cells have been successfully implemented in the maritime sector, but they also mentioned that their high price and short life are still challenged regarding their commercialization. In the fifth category, they have gave the detail about zero emission ships. And they have mentioned that it is observed that the onshore investment is less for pure electric ferries operating at short distance, while it is increased by up to 4 times for ferries powered by the hydrogen fuels. In the next slide. But we can see that there were a lot of limitations were present in this existing service because they were very specific to a specific area or category. So they were not deploying or giving us information about the different perspective or parameters or related problems to have a complete system in order to move towards the end-to-end electrification. So there were a lot of limitations were present. So there must be some. So we addressed that there should be some information available to have a complete system in place. Next slide. So in order to address the identified limitations, so our article basically has reviewed state of the art in ferry electrification, especially the ones who are already commercialized. So we have done a systematic data collection, comprehensive analysis has been performed in order to extract the information to target certain trends. For example, country-wise electrification of the vessel, leading companies, hybridization versus pure electric ships, their size, their speed, passenger capacity, or capacity in case of car carrying or for the cargo, what kind of a battery they are using, and what is the capacity. So basically, our research paper provides a holistic view of the current state of affairs that can be useful for the researcher and especially for the people in this area. Next slide. We have also presented a very fundamental concept about the electrification of the ferry, because you know that this article is also for the general public, so they can have a concept about what it is all about, what is the concept behind this electrification, and what are the important parts or components. Next slide. As you can see in this diagram, we have depicted that there is a ferry, and also it's a hybrid propulsion system in which you can see there is a battery, also a generator is attached, and PV, which is photovoltaic cells, are also present at the rooftop of the vessel. The ship is charged by the charging station at the port, and electricity is coming through the electric grid. And this electricity is green because it is coming from the wind energy forms and also the photovoltaic cells. And also we have shown that renewable energy is also, we can take from the energy waves that are inside or present at the surface of the sea, and to convert that energy into the renewable source, renewable energy. And the purpose of this renewable energy is it is very efficient, and also it produce it does not emit hazardous gases. These wind farms can also be parked at the harbor side, but the problem is the same, that there is no much land available, and also for the photovoltaic cells, a lot of investment and investors are required in order to have this. We have also shown that there is energy storage system with the charging port in case of if there is no peak is available, so then the energy can be stored into that system, and that can be utilized by the different equipments or in the harbor area. Next. So we have taken two examples from the literature. We have we discussed that if you take 24-meter long ferry with a capacity of 48 passengers and a fixed speed of 10 knots, we analyzed the same scenario for the hybrid as well as the pure electric ships, and we considered that the battery discharge is up to 80% to ensure the battery life. So in the first category, we have implemented the same scenario with the pure electric ship, and then for the hybrid ship. In the pure electric, 500 kilowatt per hour lithium-ion battery is considered, and the vessel can travel up to 44 nautical miles on a single charge. So it is a perfect example for the green transformation. But the issues that we have seen, due to technology limitation, the cost of the battery pack would be $67,500 USD. Additionally, the setup cost for a specialized high power charging station would be quite high. That is around $1 million US dollars. Similarly, the weight of the battery pack would be 3,000 kg in case of pure electric vessel. Next slide. The same scenario we have seen for the hybrid vessels, and there with the utilization of the battery was around 300 kilowatt per hour lithium-ion battery, and this vessel can travel up to 27 nautical miles on a single charge. The advantage of this approach is the reduction of battery cost, which is 40,000 now from 67,000, and the charging station require also a reduced cost. The estimated weight would be reduced to 1,800 kg from 300,000, and if we also have an energy storage system with the battery of 160 kilowatt per hour, with the generator, so then the battery cost can also be further reduced to 21,600, and the weight would be reduced to 960 kg. So we can clearly see that the difference between the implementation of this electrical strategy in the pure electric and the hybridized vessel. The aforementioned example illustrate that there is always a trade-off in the selection of an optimized solution for green transformation. Next slide. So we have used, in the research methodology section, we have used mixed method approach, because in the maritime sector you can have the values in the numeric and also in non-numeric form. The research framework model in this research articles has been developed into 3 steps. First, we discuss about the research design, and then how we are conducting the research, and then we analyze the data and further with the conclusions. Next slide. So conduction of the research was also in 3 steps. First of all, we searched some of the particular keywords, especially in this green transformation. So we, as you can see in my slides, and then we searched for particular vessels, the commercialized vessels, and also we have seen that some of the research publications who has hypothesized some of the models in order to see how these green transformation would be in a specific model for a hybrid or a electric vessel. So through those research and also applying a lot of filters, we moved and finally decided to go for a 26 commercial vessels and 10 case studies. Next slide. So the vessels that we have selected were from 2008 to 2019, aiming for a holistic vision of the vessels, and the parameters that we observed: ship name, country, company, year, powertrain, types of battery, capacity for passenger, and also the battery capacity, size, and we have selected a 26. And the reason for selection of the 26, because there were many similar vessels. So we concluded only for the relevant one and where all of these parameters were present. So the data is collected through this research and applying this mixed method approach, and then we, after collection of this data, we spread this data into the Excel sheet to get some of the trends and also conclusions. Limitations, definitely we were searching through like online sources and also through using different web services, so we cannot say that the information which is present would be accurate. There might be some bias present because we did not contact the manufacturers directly, and that would also be in a way time consuming, and sometimes they don't respond. So we tried our best to get the accurate data. Data is statistically analyzed in order to find the trends. Next slide. As you can see that in this table we have mentioned these 26 commercialized vessels, country, their and all of the other parameters. So it is in very detailed description. Next slide. And this table is related to the 10 case studies that we have gained from the research publications that used hypothesized models, especially for these research and development projects. So, next slide. So based on this data presented in this tables, we actually classified the information into 5 or 6 categories. In the country-wise electrification of the ship from 2008 to 2019, we have seen that, as you can see in this chart as well, that Denmark and Norway are the leading countries in this electric transformation, and they are doing a lot in this area. And the other countries are still moving towards the same strategy, but they are not as these countries. Next slide. In the second classification, we was based on electric and hybrid vessels, battery capacity, and vessel length. So according to the data that we have gained, the battery capacity used in the pure electric vessel is in the range of 50 to 500 kilowatt per hour, with the median value of 140 kilowatt per hour, while in hybrid ships, the range is 500 to 5,000 kilowatt per hour, with a median of 1,000 kilowatt per hour. From the analysis, it is clear that hybrid technology has an almost 10 times larger battery capacity compared to the pure electric vessel. The pure electric vessel length range is from 21 to 39 meter, while for the hybrid ship, the length range is 40 to 160 meter. The difference between the length is at least twice at minimum range, while the difference in size becomes 4 times at maximum value. The green dotted lines show the trend of battery capacity and their difference, and also the red dotted lines show the trend of vessel length. Next slide. I have already explained the graph, so I think we should move towards the next slide. In the third classification, it is about electric and hybrid vessel, like passenger or car capacity, and also the vessel speed. The passenger capacity of pure electric vessel is in the range of 75 to 1,250. It is important to note that only some of the vessels can also carry up to 240 cars. On the other hand, the hybrid vessels can transport 16 to 2,000 passengers with a median value of 150 personnel. But in addition, they can also carry 23 to 364 cars depending upon their size. The speed of pure electric vessel, as you can see, is in the range of 7 to 21 knots, and while for hybrid ships, 8 to 30 knots. From the analysis, you can clearly see that the speed of hybrid vessel is almost 1.5 times greater than that of pure electric vessel. Next slide. Next slide. In the fourth classification is about transportation, tourism, and for the other purposes. And we have seen that the transportation category basically is related to the movement of passenger from one place to another for their daily routines, for example, work, and has the widest used. Transportation of passenger, another major use of vessels in the tourism sector. It has been found that 23% of the total vessels in the last 10 years have been particularly designated for tourism, and 12% we have found is for the miscellaneous purposes, which is for the offshore supply of oil and gas. Next slide. Next slide. In this study, and also if we see the data in both of these tables, we can see that lithium-ion batteries are deployed in a great extent. So there is a shift from a lead acid to lithium-ion. One of the major reasons that we can see is the cost, which has declined from USD 917 to USD 135 in the last decade, and it is expected to be further down to 100 USD in 2021. But definitely, a lot of options are available in the recent years, but still there is a lot of research is going on. But this is we have depicted from the data that we have gained from our tables. Next slide. In the literature review, and also what we have concluded that the efficiency of the battery we can increase, and also as well as the safety through three popular methods like air cooling, liquid cooling, which is direct or indirect, and number third is the fin cooling. But there is also need to mention that each has trade-off that include cost, complexity, and power requirements. Air cooling is the most inexpensive and simplest techniques. Liquid cooling is more effective, but is more complex and costly. Fins are used for heat removal with uniformity, but extra weight is added in the system as compared to the two above methods. Heat dissipation is very much important while applying those battery systems, because if they are overheated, so it can destroy the vessel. So we can also see some of the cases in the recent years around that area. Next slide. Discussion was based on the current state of affairs and also the emerging trends and also the challenges that we have seen. In this section, we have discussed that Norway, Denmark, and Scotland are the leading countries in this particular area, and also the market share for pure electric ferries is 31% as compared to hybrid, which is 69%. Pure electric ferries can travel for short distance due to battery charging requirement, and hybrid vessels use battery technology at lower speed and in urban areas, especially during docking. Batteries are heavy and have a large volume and length in case of electric vessels. Small in the range of 21 to 39 meter with an average length of 22.5 meter. And if we see the hybrid vessels, which are long with an average length of 84.5 meter. Speed also vary. The speed of electric ferries is 7.5 to 30 knots, while the speed of hybrid vessel is from 7 to 21 knots with an average speed of 14.75 knots. Next. Next slide. Also, I have already mentioned the battery capacity. Battery capacity has already been mentioned in the graph. And there is a varying difference between these electric and hybrid vessels. And also we can clearly see through this analysis that the battery capacity of pure electric vessel is equal to the minimum range in terms of the battery capacity of hybrid vessels, while the average value is also 7 times larger. However, both types of vessels use lithium-ion battery types mainly because of economic constraint. Similar is the case with the passenger capacity and also the cargo carrying capacity. The main use of electric and hybrid vessels is in the transportation and tourism as 65% and 23% respectively. Next slide. Challenges we have discussed in terms of technical. We discussed and highlighted that grid reinforcement or the setting up of a specialized grid station that can be utilized for charging purpose is required, and the design depend upon several factors, for example, type and energy requirement of the vessel and duration of stay, as well as the distance between two ports. Renewable energy sources would be generated in the future, but not consumed completely. So we need to have a larger battery banks in order to carry those energy in different intervals of time at a constant low power. Suitable insulation is also required between these charging system and the energy storage system. An appropriate firefighting system would also be needed to handle emergency situations. Next slide. In case of operational challenges, battery technology has improved in these recent years as well, but the density is still low. And if we increase the number of batteries in a vessel, that would not be practical because it can definitely increase the size and the weight. So these are the limitations. Lithium-ion battery are available, but definitely recycling or waste management of these batteries at the end of the life is very much important because this can also cause environmental challenges. So their disassembly and crushing through standard recycling methods becomes very much important in order to get the maximum economic value and environmental impacts. Next slide. From the legislation point of view, there are many areas where legislation from the concerned authorities is required, and these areas are related to environmental impact, investment payback time, modification of existing or design of electric ferries, use of renewable energy, grid station setup, charging mechanism, and energy storage system in the port area, recycling of batteries, and so on. So the economic issues are critical and must be addressed to drive ship owners, operators to go for green transformation. Next slide. From the results, especially from the data that we have collected, and from the tables, Norway and Denmark are the leading countries in the ship electrification. 2/3 of the electrified ships operate in hybrid mode, while the remaining are pure electric. Pure electric ships are not being used for larger distances due to frequent charging requirements, while the hybrid ships are still used for longer, and they are for the longer distances. Due to the smaller size of pure electric ferries, their passenger capacity is less compared to hybrid ships. Major use of electric vessel is in transportation and tourism, although significant research is being deployed in order to see to increase the value or the capacity. Next slide. The knowledge or the state of or the review that we have done in this article can serve as one of a very small step in the implementation guide for the policymaker, academia, and other stakeholders in order to move towards the green modification while improving performance and comfort. Next slide. Lastly are the references. So these 4 to 5 slides are consist of this of the references that we have taken during the publication of this research article. And lastly or finally, thank you very much for listening me. Yeah, if you
I will say thank you to you. And are there anybody who had some questions? Little one there, maybe.
Thank you for the presentation. I was wondering where is the article so that we can read through it. The document, is that something that can be shared with us?
can you repeat your question?
Yes, I'm wondering where can I find this article or the document?
It is available online, but I will also share the link in the chat box, so you can go directly to that.
Thank you. Thank you very much. It's very interesting.
Thank you.
And we will put it on the web page of the project too. So you can go from our web page, from the project's web page, into this article too.